Good morning, dear friends. Welcome back. I hope you all are doing good, and I do pray to the God that you should always stay in a pink of health. My dear friends, this is the part 3rd of the chapter Biomolecules. So dear friends, in previous lecture I have defined many terms related to the biochemistry, especially biomolecules, then the definition of carbohydrates, old and modern definition, and then we have done classification as well. Okay, so today we are with one more classification, and that is especially of monosaccharides. If you look here, the monosaccharides contain 3 to 7 carbon atoms in their structures. That means the N value is, the N factor is 3 to 7. Which means monosaccharides can have 3 to 7 carbon atoms. Okay? So let us see the classification. Can be classified into aldoses and ketones. Monosaccharides which contain 3 to 7 carbon atoms in their structures can be classified into aldoses and ketones. So this classification is based on aldehydic and ketonic functional groups. Aldehydic and ketonic functional groups present in their structures. So let me make it very easy for you people. So this classification of monosaccharides is based on functional groups. Those monosaccharides which contain aldehyde in their structures are called as aldoses, and those monosaccharides which contain ketone in their structures are called as ketones. So I just have written aldoses and ketones. And once again I am telling you, this classification is based on the kind of functional group these monosaccharides contain in their structures. They may contain aldehyde or they may contain ketone in their structures. So they will be classified as aldoses if they have aldehyde in their structure, and they will be classified as ketones if they have ketone in their structure. So we will further discuss about aldoses and ketones, and before that I would like you people to make note of this thing. Okay, so my dear friends, let's have a look here. Let me define first of all aldoses. As I told you that aldoses are basically the monosaccharides which contain aldehyde as a functional group in their structures. So now we know that aldoses are monosaccharides, and monosaccharides contain 3 to 7 carbon atoms in their structures. So based on the number of carbon atoms here, what we have done actually, we have further given some examples of aldoses based on carbon atoms. If you look at the first, it's aldotriose. Okay, tri basically means 3. You can have a look. Here we have 3 carbon atoms. Tetra means 4 carbon. Pent means 5. Hex means 6. And hept means 7. So now in these aldoses, these are the examples of aldoses, my dear friends. These are all examples of aldoses containing 3 to 7 carbon atoms. Look here, from 3 to 7 carbon atoms they contain. Okay? And obviously as they are aldoses, they will also contain aldehyde in their structure. If you look in all these molecular structures, they should have aldehyde in them. I'll give 1 or 2 examples to demonstrate that. So let us talk about the first term here. Aldose stands for, as everybody knows, it means aldehyde. And then we have a term tri here. Tri means actually 3 carbon atoms. We have 3 carbon atoms. And Os, O-S-E, Os. What is the meaning of Os? Let us understand. It's also pronounced as Os, or you can say Os. It is basically, let me write it down because there may be a little reflection. So Os I will write down here. It is a postfix, we can call it as. We can also call it as suffix. What is the meaning? It's used to represent sugar. So this term Os is used to represent sugar. So my dear friends, if I have here aldotriose, that means this compound contains aldehyde and with 3 carbon atoms. And remember, in these 3 carbon atoms, one carbon atom will be aldehyde. Okay? And Os means sugar. So now let us define aldotriose. Aldotriose are those monosaccharides which contain 3 carbon atoms, and among them 1 carbon atom is basically aldehyde. Out of 3 carbons, 1 is aldehyde, and it's a sugar. An example of that is glycerol aldehyde. Then obviously it is Ketones. It should contain 4 carbon atoms, and 1 carbon atom among 4 carbon atoms will be again aldehyde, and O stands for sugar. So its molecular formula is C4H8O4, and the example is erythrose and threose. These are the examples. So let's go further. Aldopentose, as usual now, 5 carbon atoms. Pen stands for 5 carbon atoms. 1 carbon atom out of 5 will be aldehyde, and Os means sugar. Again, aldohexose. Hex means 6 carbon atoms. Out of 6 carbon atoms, 1 carbon atom will be aldehyde, and it's a sugar. Which sugar is it? It's a monosaccharide. Molecular formula is C6H12O6. So you can take example of pentose sugars like arabinose, ribose and xylose. These are the examples of pentose sugars. Glucose, galactose and mannose. These are the examples of aldohexoses. And finally, if you see, we have aldohaptoses. Okay? Aldo is again aldehyde. Hapt means 7 carbon atoms, and out of 7 carbon atoms, 1 carbon atom will be aldehyde. Okay? And Os stands for sugar, or Os stands for sugar. Molecular formula is C7H14O7, and the example is L-glycerol D-manohaptose. This is an example of aldohaptose. So my dear friends, in one line I will tell you that aldoses are those monosaccharides which contain aldehyde as a functional group in their structures. And remember, aldoses are monosaccharides and they should contain 3 to 7 carbon atoms in their structures, not less or more than that. You can't have 2 carbon monosaccharide and you can't have 8 carbon monosaccharide. You can have only 3 carbon. Tri means 3 carbon monosaccharide. 2 Hapt means 7 carbon monosaccharide. And all these structures contain aldehyde as a functional group. So they are called as aldoses. And these are the examples which I have given right out here. Okay, now you'll be thinking that let us see 1 or 2 structures right out here so that you can understand whether they contain aldehyde or not. Let me take the first example. Glycerol aldehyde I will take, and I will take the glucose just to show you whether they contain aldehyde or not. Let us see. Let's take on this example. Glycerol aldehyde. I will draw its structure a little down so that it will be visible here. So my dear friends, it contains tri means it contains 3 carbon atoms. So 1, 2 and 3. So it's 1, 2 and 3 carbon atoms. Out of these 3 carbon atoms, 1 carbon atom will be aldehyde. So 1 carbon will be aldehyde, and obviously aldehyde comes at the terminal position. So obviously aldehyde will come here at the terminal position. So this aldehyde. So how many carbon atoms I have? 3. 1, 2 and 3 carbons. Okay? And the first carbon is nothing but aldehyde. Now look at the second carbon, you will be having OH here, H. And the third carbon will be CH2OH. Now my dear friends, if I mention here also, I can mention for you people carbon atom here. Okay? 1, 2 and 3 carbon atoms. Out of 3 carbon atoms, 1 carbon atom is aldehyde. This is aldehyde. And now my dear friends, this will be considered as aldo because it contains aldehyde. And 3 carbons are there, 1, 2 and 3. So I'll call it as tri. And we know this glycerol aldehyde is a sugar. It's a monosaccharide. And for sugars we are using the suffix. Which suffix we are using for sugars? Os or Os we can say. So I will use here OSE. I hope you have understood this example. Let me give you one more example here. I hope you have made the note of this. Okay, so let us go further for glucose molecule. Let me draw the structure of glucose here. So let us see the glucose molecule. It's also aldose. Okay. Let's have a look, my dear friend. If I talk of glucose, its molecular formula is C6H12O6. So let's draw the structure. And I know that it is aldose. Okay. So it will have aldehyde in its structure. So this is aldehyde, the first carbon. Then you have second carbon, third, fourth, fifth, and the last one is sixth carbon. So 1, 2, 3, 4, 5 and 6. Sixth carbon, everybody knows it's CH2OH. And I told you previous time that the third carbon has OH group on left side. Remember that. Third carbon OH group left side. Second, fourth and fifth carbon has OH group on right side. And rest of the valency is satisfied by hydrogen atom. Okay. Now what I want to say here is that it contains aldehyde. So I will use term aldo. It has 6 carbon atoms in it. So hex. And I know that it's a sugar. Glucose is a sugar molecule. So I use O's. So it's aldohexose, my dear friends. 6 carbon sugar. So with this, we'll move on to the ketosis after this. So now let us come to the ketosis. My dear friends, what are ketoses? These are the monosaccharides which contain ketonic group in their structures. Means ketone as a functional group in their structures. And everybody knows these ketoses are also monosaccharides. So the number of carbon atoms should be from 3 to 7. So you can have a look. From 3 to 7 we have number of carbon atoms in ketosis. Just like aldoses. Aldoses contain aldehyde as functional group. Ketoses contain ketonic group as a functional group. Correct? And now let's come to the terms. Ketotriose. The ketotriose means actually those monosaccharides which contain ketone, and tri means 3 carbon atoms and 1 carbon atom will be ketone. Here functional group ketone is there and contains 4 carbon atoms and 1 carbon atom will be ketone. So it contains 5 carbon atoms, 6 and then finally 7 carbon atoms, and each of these molecules contains ketonic group. Okay? And their molecular formulas are exactly similar to that of aldoses. Now let's have a look around. If we take examples here, the first example is dihydroxyacetone. This dihydroxyacetone should contain 3 carbon atoms and it should have a ketone as a functional group in it. So let us see the structure of dihydroxyacetone. Dihydroxyacetone. So my dear friends, it's a 3-carbon sugar. So let me draw it like this. The first carbon, if you look here, has to be not the ketone, because ketone exists within the chain. So when ketone exists within the chain, that means I cannot have 2 valencies here. So I have to remove the 1 valency from this side, and I have to put the ketonic group in the middle. So let me draw the carbon here, and let me make it as a ketonic group. Because everybody knows that ketone can have 2 free valencies. And 1 valency will be satisfied by CH2OH, and another valency will be also satisfied by CH2OH. Ketone is the functional group which comes in the middle of a particular chain. Why? Because it has 2 free valencies. Aldehyde will always exist at the terminal. Okay? Let's do the numbering for this. 1, 2 and 3. So this molecule contains ketone. So we call it as ketone, containing ketone. Tri stands for 3 carbon atoms. Have a look. 1, 2 and 3 carbon atoms are here. Out of these 3 carbon atoms, 1 carbon atom is ketonic group. So you have a ketone here as 1 carbon. And O's, it is being pronounced as O's or O's. It stands for sugar. And it's basically called as postfix, or you can call it as suffix. And it stands for sugar. So what do you mean by now dihydroxyacetone? It contains ketone, so it's ketone. It contains 3 carbon atoms, so it's tri. And obviously it's a monosaccharide, it's a sugar. So obviously it is O's. That is ketotriose we have here. I hope you have understood this particular example. And exactly the others will follow the same pattern. This guy will contain 4 carbon atoms and 1 carbon atom will be ketone. Exactly the last one we have ketohaptose. It will contain 7 carbon atoms and 1 carbon atom, which will be second carbon, will be a ketone. Okay? And it's a sugar. Now let's take examples. For ketotrioses we have dihydroxyacetone. Ketotetrose, 4 carbon sugar, we have erythrulose. And then for ketopentose, we have ribulose, or we can say ribulose and xylulose. And then for 6 carbon sugar, which contains ketone as functional group, we have fructose and we have sorbose. And finally we have the 7 carbon sugar, which is a ketose actually. We have pseudohaptulose, or it's also known as D-altrohaptulose. D-altrohaptulose or pseudohaptulose. So in a nutshell, I would like to tell you, ketoses are basically those monosaccharides which contain ketone as a functional group in their structures. And they are ranging from carbon 3 to carbon 7. Less than carbon 3, you can't call them as ketoses, or more than carbon 7, you can't call them as ketoses. 3 to 7 is a range. And these are the examples of ketoses with their molecular formula. So my dear friends, we have discussed about aldoses and ketoses. Okay? They are monosaccharides containing 3 to 7 carbon atoms. Aldoses contain aldehyde. Ketoses contain ketone in their structures. Now, one important point I want to write down here, okay, that is functional isomers. Now, I felt the need of this to mention it here because we are already done with aldoses and ketoses. Aldose and ketose, they can be functional isomers. Let's have a look. What is required? They should have same molecular formulae, but they should have different functional groups in their structures. So let's have a look. Let me take an example here and let me show you whether they can be functional isomers or not. Have a look. Let us start with the first one called as aldose and then ketose. The first condition is that their molecular formula should be same. So let's have a look. C3H6O3, here also C3H6O3. So the molecular formula is same, but the functional groups will be different. So I can call it as here molecular formula. So what is the molecular formula for these substances? Have a look. C3H6O3, C3H6O3. Now the functional groups will be different. Or shall I write down like this? Same molecular formula, but here I will write down different functional groups. So what are those functional groups? Have a look. Obviously this is aldose, it will contain aldehyde. Okay, so aldehyde will be a functional group here. This is aldehyde as functional group. And this guy will have ketone as functional group. So this is ketone. So what is this molecule all about? This molecule is a 3-carbon atom monosaccharide sugar. This is basically glycerolaldehyde. And this guy is a ketose and it's a dihydroxyacetone. So my dear friends, glycerolaldehyde and dihydroxyacetone, they have same molecular formula, but their functional groups are different. This guy has aldehyde and this guy has ketone. You can see the structures as well. For glycerolaldehyde, have a look. You can have an aldehyde group here, then you have OH, H, and finally CH2OH. Here we have aldehyde as functional group. And for the dihydroxyacetone, you can have here ketonic group will be in the middle. So here we have CH2OH and here we have CH2OH. So here we have ketone as functional group and here we have aldehyde as functional group. And if you look at their molecular structures, it is C3H6O3 for both of them. C3H6O3. This contains aldehyde, this contains ketone. So obviously they have different functional groups. When they have different functional groups, they will be considered as functional isomers. So these two are the functional isomers. Glycerolaldehyde is a functional isomer of dihydroxyacetone. In the same way, if we talk of glucose and we talk of fructose, these two also have same molecular formula. Glucose contains aldehyde and the fructose contains ketone. So obviously they have different functional groups. They will be the functional isomers. Glucose and fructose, glycerolaldehyde and dihydroxyacetone. These two are functional isomers. So if I put examples here, 2 examples, I will write down like this. Glycerolaldehyde and dihydroxyacetone are functional isomers. In the same way, our glucose molecule and fructose molecule are also functional isomers. How they are functional isomers? Everybody knows. Glucose C6H12O6, fructose C6H12O6, molecular formula is same. This guy contains aldehyde and this guy contains ketone, so they are functional isomers. So I hope you have understood this example. You can have a brief idea here. Let me draw this here. This is aldehyde, second, third, fourth, fifth, and this is the last carbon, sixth carbon, CH2OH. And I told you that 1, 2, third carbon has OH group on the left side, and rest have the OH group on the right side. So this is the structure of the glucose molecule, and it contains aldehyde. Now the second carbon will be ketone. Here we have CH2OH. The first carbon, second and third carbon will have OH group on the left side, H. Then fourth carbon OH, fifth carbon OH, and finally you have CH2OH. Fourth, fifth, sixth, then you have H and H. Here we have ketone, here we have aldehyde. And the molecular formula, this is our fructose molecule. It contains ketone, glucose contains aldehyde, and their molecular formula is same. What is that? C6H12O6, but their functional groups are different. Aldehyde and ketone, they are different. So we can call them as glucose and fructose are functional isomers. So my dear friends, our topic is moving on. So let's have a look. The carbohydrates can be further classified into sugars and non-sugars. Okay? So what are sugars? First of all, we'll have a look. Sugars are crystalline substances. What do you mean by crystalline substances? They have well-defined arrangement of molecules in their structures. Or you can say they have well-defined arrangement of atoms in their structures. So they are crystalline substances. Second point, they are soluble in water. That means the sugars are soluble in water. They dissolve in water and are sweet in taste. Yummy, yummy, sweet in taste. So we call them as sugars. So my dear friends, sugars are crystalline substances. That means they have a well-defined arrangement of molecules in their structures. Second thing, they are soluble in water. And the third point is they are sweet in taste. Examples are monosaccharides. I have already discussed about monosaccharides. You will be having glucose, fructose, mannose, galactose, sorbose, ribose, ribulose, threose, yes, xylose. There are so many monosaccharides which I have already discussed. So they are all sweet in taste and they are sugars. And even disaccharides. And I told you last time that this disaccharide is a part of oligosaccharides. So they are also considered as sugars. Monosaccharides and disaccharides are considered as sugars. So let's have a look at non-sugars. Non-sugars are amorphous substances. Amorphous means they don't have a particular arrangement of molecules in their structures. A regular arrangement will be there, okay, or a very much messed up arrangement in their molecules. They are insoluble in water, they don't dissolve in water. And finally, they are not sweet in taste, they are tasteless, okay. Examples are polysaccharides. When you take starch, for example, when you take rice, you'll find out that there is not much taste into that. So we can consider it as a tasteless substances because it's not sweet. Rice is not a sweet in taste. So it's tasteless, and that rice is nothing but it's your starch. So obviously it's a non-sugar. Other examples of cellulose and glycogen. These are the non-sugars. I hope you have understood this thing. So let us start, guys. Let's talk about occurrence. And occurrence we can say and preparation of glucose. First of all, we will talk about the occurrence of glucose. That how, in which form the glucose exists in nature. We have to look into that. So our first topic will be the occurrence of glucose. Glucose is known as grape sugar. Okay? Why it's known as grape sugar? We will get to know about it. It's also known as dextrose. This thing also we'll discuss. And everybody knows the molecular formula of glucose is C6H12O6. So my dear friends, let's talk about occurrence. The glucose exists in nature, okay, either in a free state all alone. or in a combined state. Free state means just glucose, not attached to with somebody else. But in combined state, it interacts with other glucose molecules and forms the bigger chains, which later on turn out to be polysaccharides or polymers, we call them as. Okay. So my dear friends, in free state, if you look here, in free state, glucose is about 20% in ripe grapes, or we can say ripened grapes, 20%. So that's why it is known as grape sugar. So 20% presence in ripe grapes, so called as grape sugar. I hope you have understood this term, grape sugar now. Glucose, it is also present in sweet fruits, like mangoes, honey, apples, peach, pears. And I will remove this term right out here, honey, because it's not a fruit. So I will mention it as here. Also present in honey. Because let me take the fruits to one side: mangoes, apples, peach and pears. And finally in the honey. In these fruits and other substances, it's present in the form of glucose only, that is free state. But when we talk of the combined state, it occurs in disaccharides, because disaccharides are made up of more than one monosaccharide units. So disaccharides and polysaccharides are basically the combined state of glucose. You can take an example of disaccharides as maltose. It is made from two glucose molecules. That means combined state. Glucose and glucose combines and forms maltose. In polysaccharides, you can take an example of starch. You can take an example of cellulose. You can take an example of glycogen. In all of these, large number of glucose molecules combine. The range is from 100 to 3000, to form these polysaccharides. So obviously, these are the combined state of glucose. I hope you have understood the free state and combined state. In free state, it will be present in grapes, in sweet fruits like mangoes, apples, peach, pears, and also present in honey because they are sweet in taste. But in combined state, like glucose will not be alone, it will be present with other glucose molecules. So in combined state, it will be present in disaccharides and polysaccharides. So now I will explain you one more term here. What is that? Dextrose meaning. So let us see the meaning of dextrose. So have a look. The term dextrose, if I talk about, glucose is known as, let's make a note here. So I am defining this term, it is known as dextrose because it can rotate the monochromatic light, or you can say plane polarized light, monochromatic light in clockwise direction. That means it's optically active. Last time I told you, if I take the solution of glucose, it can rotate, the solution of glucose can rotate the monochromatic light in clockwise direction. And that's why it is known as dextrose. Dextrose can be also related to like dextrorotatory. Dextrose means dextrorotatory, which can rotate the light in clockwise direction. I discussed it with you friends that the glucose can occur in two states. Free state all alone, or in combined state means with other glucose molecules. In free state it exists in the grapes, peach, apples, honey and many more substances. But in combined state, it exists in disaccharides, or you can say oligosaccharides and polysaccharides. So let's move on to the preparation. How can we prepare the glucose molecule? First of all, we can prepare it from sucrose. What is this all about? This guy is our disaccharide. And everybody knows this is the combined state of glucose. This is the combined state, not free state, combined state of glucose. Because in disaccharide we have the glucose, it's made up of glucose and fructose. This disaccharide, especially I am talking about sucrose. So my dear friends, what I am doing here, I am doing hydrolysis, which I discussed previous time. So this guy is nothing but it's my sucrose. It's a disaccharide. Okay? And we have glucose in a combined state of glucose with fructose. That means glucose is in combination with fructose here. So addition of water I am doing to the sucrose molecule, okay? But in acidic medium, this acidic medium is basically here. We can use dilute HCl or we can use H2SO4. We should not use concentrated acid. We have to boil the sucrose with dilute acid. The reason is that if we use concentrated acid, what will happen? This sucrose molecule will burn and you won't be getting the glucose and fructose here, you will be getting carbon black. Okay, the black carbon you will be getting only because it will lose all the water will be lost and only carbon will remain there when you are using concentrated H2SO4. But my dear friends, I am using dilute HCl or H2SO4, so I won't be getting carbon, but I will be getting here the glucose and fructose. So my dear friends, I can prepare the glucose from sucrose. How? I will take the sucrose molecule and now I am adding the water to the sucrose in presence of an acid. This is known as actually acid hydrolysis, which means I am adding water in presence of an acid, so it becomes acid hydrolysis. This sucrose molecule will break into two parts by the addition of water. And those two parts are glucose and fructose. Now this is actually the free state of glucose. This is now free state. But in sucrose, actually it is present in which state? Combined state. With whom? Glucose is in combination with fructose. But when I am doing acid hydrolysis, I am using dilute acid. I told you why. When I am doing acid hydrolysis of sucrose, it breaks into the glucose and fructose, so I am getting the free state of glucose here. Okay, so this is one method of preparation of glucose from the sucrose molecule. Now finally let us come to the another term here from starch. Everybody knows that starch is nothing but it's a polysaccharide. And everybody knows that polysaccharide contains large number of glucose units. Means it will be having, I told you last time, the N value can be from 100 to 3000. So you can have 100 to 3000 glucose units in the starch. So that's why what you do, this is the general formula of your starch. So when you do acid hydrolysis, again you are adding water n times in presence of a dilute acid. But here you require actually temperature, 393 Kelvin temperature. Why temperature is required? Because we require temperature only so that more and more kinetic energy will be given to these two molecules which are reactants. This temperature will give kinetic energy to these molecules and they will start colliding with each other. Collisions will happen. Then we have two types of collisions. The collisions can be either effective collision or random collision. But when effective collision happens, then reactants can change into products. But when random collisions happen, okay, what happens? Reactants do not change into products. When we are giving high temperature, what will happen? These guys will get more and more kinetic energy. They will start colliding with each other. Water and starch, they will collide with each other. Millions of molecules will keep on colliding. And then effective collision will happen. Due to effective collision, what will happen? These reactants can change into product. And this product is nothing but it's our glucose. How many times? N times. And this N can be 100 to 3000 molecules of glucose you will get. That's why this is also known as, this reaction if I talk about, this is also known as commercial production of glucose. That means if I have to prepare the glucose in the industries, I'll be using this second reaction, not the first reaction. Because first reaction gives me only one glucose molecule. But second reaction can give me N times glucose. N times means 100 to 3000 glucose molecules. So at commercial level, in industries, I'll be preferring the second reaction. That is, I can prepare the glucose from starch. Large amount of glucose I can prepare. So my dear friends, you will be thinking of this pressure. Why do I use pressure? 2 to 3 atmospheres of pressure also I am using. What is the role of pressure? I will give the little idea here. When you apply more pressure on reactant molecules is starch and water. When you apply more pressure on them, molecules come closer. When you apply pressure on the reactants, molecules come closer, 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 because density will increase. When they come closer, they can collide. Once they collide, what will happen? Effective collision chances will increase. Once the effective collision increases, chances of effective collisions increases, or their frequency increases, what will happen? The reactants can change into product, that is glucose. So my dear friends, I hope you have understood what is the role of temperature and what is the role of pressure in this particular reaction. So these were the two methods by which we can prepare the glucose. There are other methods as well, but the first one, we'll prepare the less amount of glucose, just one molecule. But in second, from one molecule of starch, I can prepare N times glucose, and that N can range from 100 to 3000. So my dear friends, the second one is the commercial production of glucose. I hope you have understood. This is all for today. May God bless you. Yo-yo. Thank you.